Only 1% got this right. Let's see the question. We have 2 raised to the power of x plus 4x equals to 12. Now asked to prove if x equals to 2. The value of x is 2 because if you put 2 here, 2 raised to the power of 2 which is 4, and 4 times 2 is 8. So 4 plus 8 is 12. So we are asked to prove. Very simple, okay? Let's solve it together. Now our first step, what we're going to do is we're going to subtract 4x from both sides of the equation. So if we do that, we're going to add that this is 2 raised to the power of x is equals to 12 minus 4x, because we subtracted 4x from both sides of the equation. Second step, we're going to add this is 2 raised to the power of x is equals to. Now let's observe between 12 and 4x. What is common? 4 is common because 4 can go to 12 without remainder, and 4 can also go to here without remainder. So 4 is common, okay? Into 12 divided by 4 will give us 3. Minus 4x divided by 4 will give us minus x, okay? Wow, this is amazing. Now, our third step, what we're going to do, we're going to divide both sides by 2 raised to the power of x. So if we divide here by 2 raised to the power of x, and divide the whole of this by 2 raised to the power of x. Now, 2 to the power of x divided by 2 to the power of x is 1 by the properties of indices. So this is 1 equals what? Now we can write the whole of this as 4 multiplied by into 3 minus x multiplied by what? 2 raised to the power of minus x. If we really obey the properties of indices, we know that 2 raised to the power of minus x is the same thing as all this divided by 2 raised to the power of x, okay? Now, our first step, what we're going to do is to divide both sides by 4. So if we divide the whole of this by 4 and divide the whole of this by 4, you all agree that this will also add this, and we are left that 1 over 4 is equals to into 3 minus x, then multiply by 2 raised to the power of minus what? X. Wow, this is Procacerineous, right? Now, our first step, what you're going to do, since here is 3 minus x, and we want the same thing to be at this power here. What is at this power? Just minus s. What you have in here is 3 minus s. So for us to achieve that, what you have to do is to multiply both sides by 2 raised to the power of 3. If we can do that, we can achieve this in form of this, okay? So if we multiply here by what? By 2 raised to the power of 3, we would have 1 divided by 4 multiplied by 2 raised to the power of 3 is equals to into 3 minus x, then multiply by what? 2 raised to the power of minus x, then multiply by 2 raised to the power of 3. Because we multiply both sides by 2 raised to the power of 3. Okay? Now this time, we're going to have 2 raised to the power of 3, then divided by what? 4. Because 1 times 2 raised to the power of 3 is 2 raised to the power of 3. And the denominator of this is 1, right? So 4 times 1 will give us 4. Equals what? Into 3 minus x, then multiply by 2 raised to the power of what? Now, if we obey the properties of indices, the multiplication law of indices, we all agree that since the bases are the same, we can take a single base and add the exponents, right? Now, this now become what? Minus x, right? Plus what? Plus 3. Wow, this is fantastic. Now, I can also write minus x plus 3 as x minus 3, right? So, from here, I'm going to add this is what? 2 raised to the power of 3, then divided by 2 raised to the power of 2. Because I can write 4 in index form as 2 raised to the power of 2 to represent 4. Then equals what? Into 3 minus x, then multiply by what? 2 raised to the power what? 3 minus what? X. Wow, this is amazing, right? Now, let's obey the properties of indices, the division law of indices from here. We now agree that this is something as 2 raised to the power of 3 minus 2, right? If you obey the division law of indices, you know what happened there. Then equals to what? Into 3 minus what? X, then multiply by 2 raised to the power what? 3 minus what? X. You can observe carefully that what is here, which is 3 minus x, is also equals to what is the power, which is 3 minus x. That's what we are looking for, okay? Now, 3 minus 2 is 1. So your here is just 2 equals what? Into 3 minus x, then multiply by 2 raised to the power 3 minus x. Wow, this is amazing, right? Now, there's one of the properties of logarithm I want to introduce here so that this question can be easy and beautiful to solve. We know by the definition of logarithm and the properties of logarithm, we all agree that e raised to the power of link a, okay, is equals to what? A. This is one of the properties of what? Of logarithm we have to take note. Okay? So that means 2 is equals to into 3 minus x, then multiply by, in place of this 2 raised to the power of 3 minus x, I can decide to write as what? E raised to the power of what? Link, then 2 to the power of 3 minus x. There's nothing changed. Because I know if I obey the properties of logarithm that e raised to the power of link a is equals to a, it implies that e raised to the power of link 2 raised to the power of 3 minus s is the same thing as this by obeying this law, right? And there's another law in logarithm that says that the index here can also go back to multiply the link. So that is 2 equals what? Into 3 minus x, then multiply by e raised to the power what? Into 3 minus x, then link what? Link 2. Wow, this is fantastic, right? Amazing. Now what you have in here is link 3, and what is here is link 3 minus x. What is here 3 minus x link 2. So there's a properties of Lambda derivative function which said that the derivative function of what? The derivative function of into a multiplied by e to a is equals to what? A. This is a properties of Lambda derivative function. So this is 100% truth. So if this e you're seeing is this e you're seeing here, and a is what you are seeing here, you can observe that the a is not equal to what is here, right? So because the a here and the a here must be the same, and what is here is 3x 3 minus s link 2, and what is here just 3 minus x. So what you are going to do so that you can achieve this, right? This and this can be the same, is to multiply both equation by link 2, right? So if I multiply here by link 2, that this is 2 link 2, okay, equals to and into 3 minus s multiplied by 1 link 2, okay, then multiply by e raised to the power what? Into 3 minus x, then what? Link what? Then link 2, right? Link 2. Wow, it's amazing, right? Now I'll achieve what I'm looking for, okay? Now at this point, what I'm going to do is to take the Lambda derivative function of both sides. So that means the Lambda derivative function of, will there be space for this? Let me clean here. Okay, let me remove from here, please. All right, this is amazing, beautiful question. Okay, how to find the value of x, and they say you should prove that s is 2. So we are trying to prove the value of x. Okay, all right. Now, so the Lambda derivative function of 2 link 2, okay, is equals to the Lambda derivative function of what? Bracket then into 3 minus x, right? Then link what? Link 2. So let me remove this, please. Okay, then e raised to the power what? Multiply by e raised to the power into 3 minus x, then link 2, then close. So by definition, that the Lambda derivative function a multiplied by e to a is equals to a. It means that what to be added here is just what? Is just 3 minus s link 2, right? So that this is the derivative function of what? Into 2 link 2 is 3 minus what? S, then what? Link 2. This is procartesian, right? And amazing. Remember, we are asked to prove that s is equals to 2, and that's what we are doing. Now, don't forget that e raised to the power of link a is what? A. Don't forget, it's very important. So, do you know what I'm going to do? Are you seeing 2 here? I can decide to write this 2. Do you know that 2 is equals to e raised to the power of link 2? Take note that 2 is equals to e raised to the power of link 2. So, in place of this 2, I can write that the derivative function of what? Into e raised to the power of link 2, then multiply by what? Link 2 is equals to into 3 minus s, then multiply by link what? Link 2. Now, what will be added here by obeying the properties of Lambda is just link 2. So, link 2 is equals to 3 minus s, then multiply by link what? Link 2. So, if I divide here by link 2, okay, I also divide here by what? Link 2. Are you seeing? This will cancel out this. And link 2 divided by link 2 is just 1, equals to 3 minus x. Because what will be left here is just 3 minus x. And if we subtract 3 from both sides, we're going to add down 1 minus 3 is equals to 3 minus 3 minus x. Okay? And 1 minus 3 is minus 2 equals to 3 minus 3 is 0. 0 minus s is minus x. And remember, our target is to find the value of x. So for us to determine the value of s, we'll have to multiply both sides by the coefficient of x, which is minus 1. So minus 1 is equals to minus what? 2. So if we divide here by minus 1, minus s equals to minus 2. So coefficient of x is minus 1. So if this cancel out this, we'll see that our x is equals to what? 2. Because minus will cancel out minus, we are left at 2 divided by 1, which is 2. So you can see that we have proved that our x is equals to what? 2. It's only 1% did this correctly, okay? So that means if x is 2, 2 to the power of 2 will give us 4. 4 times 2 is 8, and 8 plus 4 will give us 12. This is pocket continuous and amazing. So thank you so much for watching. Please, you find it very interesting, don't hesitate. Do it to like, comment, and share to loved ones or others who learn from it. So thank you so much, and God bless you. Bye. And again, if you're not subscribed, consider to subscribe so anytime I upload exciting videos.